This video provides an overview of End-Around Taxiways by the Office of Airports at the Federal Aviation Administration. For information on End-Around Taxiways, refer to Advisory Circular AC 150/5300-13, Airport Design, for specific design standards. See www.faa.gov. Images in this video are graphical representations only and are not to scale. Discussion topics include overview, aircraft, departure and approach surfaces, visual screen, and end-around taxiway examples. Overview. To increase operational capacity, many airports have added multiple parallel runways. Delays often occur when traffic lands on an outboard runway and crosses an inboard departure runway. The forecasted growth in national airport operations may further increase these delays. An end-around taxiway, or EAT, allows taxiing aircraft to cross the extended runway centerline without specific clearance from air traffic control. This improves the efficiency of airport operations and provides an alternative to taxiing aircraft across a runway. A properly designed EAT with its associated visual screen does not interfere with navigational aids, safety areas, or runway approach and departure surfaces. The EAT's design considers parameters unique to each airport and each runway. It is recommended practice to construct the EAT below the runway end elevation. This minimizes the necessary distance between the end of the runway and points along that portion of the EAT crossing the extended runway centerline. The aircraft types are important EAT design factors. Consider these three aircraft dimensions when designing an EAT. The H-sub-I dimension is the height of the pilot's eye above the pavement for the critical aircraft taking off on the runway. The H-sub-nacelle dimension is the height of the engine's nacelle above the pavement for the critical aircraft on the EAT. The H-sub-tail dimension is the tail height above the pavement of the critical aircraft on the EAT. Departure and approach surfaces. This plan view shows the relationship of an aircraft on the runway, an aircraft on the EAT, and the visual screen. V1 is the aircraft speed at the point which a pilot decides to abort a takeoff if the aircraft is going to stop on the runway. The pilot can clearly determine that the taxiing aircraft is either on the EAT or crossing the end of the runway. The visual screen aids in this determination by masking the departing pilot's view of the taxiing aircraft's engine nacelle. Using this information, the pilot decides whether or not to proceed with the takeoff. This is a cockpit view of an aircraft taking off. Before the V1 point, an aircraft enters the field of view from the left. Upon reaching the V1 point, the pilot clearly determines that the taxiing aircraft is not crossing the runway when the visual screen masks the view of the engine's nacelle. With this information, the pilot establishes that the passing aircraft is not on the runway, allowing the pilot to proceed with the takeoff. This is a plan view of an EAT displaying the departure surfaces. The Airport Design AC contains guidance on approach and departure surfaces information for the initial planning and design of an EAT. Runways with instrument procedures involve a final review by the flight procedures team to ensure taxiing aircraft do not conflict with these procedures. As the aircraft taxis on the EAT, neither its wings nor tail may penetrate the approach and departure surfaces. At a certain distance from the runway, the aircraft can taxi under these surfaces without conflict. Consider all elevations of the runway end and the taxiway. Locate the EAT to ensure that the 40:1 departure surface is free of penetrations. With clear EAT approach and departure surfaces, the airport can simultaneously conduct taxiing and takeoff operations. A visual screen is an important element for an EAT. The screen size and diagonal red and white stripes are conspicuous and recognizable to pilots. Through a partial or complete masking effect, the visual screen informs pilots on the runway whether an aircraft is crossing the active runway or operating on the EAT. The use of reflective screen material negates the need for additional nighttime lighting. A visual screen is not necessary if the airport's terrain masks the pilot's eye-level view of the EAT aircraft's engine nacelle. Design EATs for local conditions. Refer to AC 150/5300-13 for detailed information regarding equations and calculations for EAT and visual screen design. In the following three real-world examples, the EATs may look different, but their designs use the same criteria explained in this video and the AC. The first example is an EAT at Detroit Metropolitan Wayne County Airport. This configuration uses a single visual screen. The second example is an EAT at Dallas-Fort Worth International Airport. Because this EAT traverses through two extended runway centerlines, this configuration uses two visual screens. The third example is an EAT at Hartsfield-Jackson Atlanta International Airport. A visual screen is not necessary for this EAT. The EAT's elevation is low enough compared to the runway end elevation that the airport's ground terrain sufficiently blocks the pilot's view of the aircraft on the EAT. These reference materials provide guidance on end-around taxiway design. Please visit www.faa.gov to find documents, videos, and other related resources. The FAA appreciates your interest. Safe flying!